folks, welcome to the lesson, the surface area of a triangular faced prism. You might have no idea what one of those is, but don't worry, I'll show you. So let's crack on and get the job done. A prism is a shape which has a constant cross-sectional area running from front to back or top to bottom or left to right. In this case, it's from front to back. And that constant cross-sectional area is this red triangle. So if a shape has a constant area running through it, it's a prism. So here we have a triangular faced prism, and it's made up of one side, a base, a front triangle, and a back triangle, and finally a sloping face. So that's 3 rectangles and 2 triangles. Here is our first example then. The side is a blue rectangle and the lengths are 5 centimeters on the height and 10 centimeters on the width, giving an area of 50 square centimeters. As for the base, that's a rectangle of 4 centimeters by 10 centimeters, giving an area of 40 square centimeters. The front triangle, using half base times height, would be an area of 4 times 5 divided by 2, and that would be 10 square centimeters. And of course the back triangle, because it's exactly the same dimensions, also has an area of 10 square centimeters. For the sloping face, we have a width of 10 centimeters, but the height is the length d, which we don't know. So we have to find the length d. We use the back triangle. Remember, the dimensions of the back triangle are 4 centimeters by 5 centimeters, and therefore we use Pythagoras. D squared, which would be the hypotenuse, d squared equals 4 squared plus 5 squared. D squared equals 41, and we will square root that to give us a length of d equal to root 41 centimeters. We can put that into our dimensions, giving an area now of that sloping face of 10 times root 41. All that's left to do now is to put these areas together. That's the 50 square centimeters, 40 square centimeters, the triangles, each 10 square centimeters, and that sloping face, and we add them together, giving a final total, rounded off to 3 significant figures, of 174 square centimeters. Let's try this again with a second example. The dimensions of the blue side are 6 centimeters in height and 12 centimeters in width, giving an area of 72 square centimeters. For the base, that's a rectangle, 5 centimeters by 12 centimeters, that's 60 square centimeters. The front triangle, using half the base times the height, would be a half of 6 times 5, which is the same as 6 times 5 divided by 2, and that would be 15 square centimeters. And of course, the back triangle, being exactly the same size, is 15 square centimeters. For the sloping face, the width is 12 centimeters, the height is d, which we need to find. We use the back triangle, the dimensions of which are 5 centimeters by 6 centimeters, and we will use Pythagoras again. D squared equals 6 squared plus 5 squared. D squared equals 61, so D equals the square root of 61. Now that gives us an area of the slope of 12 times root 61 squared centimeters. All that's left to do is to put all those areas together, the side, the base, two triangles, and the sloping side, giving a total area of 256 squared centimeters when rounded off to three significant figures. Let's put all this together then with a recap. A triangular face prism has a fixed size triangle running through it. In this case, it runs from front to back, and that's what makes it a prism. The surface area is made up of three rectangles and two triangles. The rectangles are the side, the base, and the sloping side, and the two triangles, one at the front and one at the back. And if there's anything about the video you haven't understood, just watch it back, and if you have, that's great, because that's the job done.